All right, guys, the very last chapter of this unit, or the section of this chapter. How can we deal with this water pollution thing? Well, the key is really the non-point pollution, right? That's the hard one to monitor, take care of, and manage. And remember, the vast majority of that comes from agriculture. So the key here with this non-point stuff is to keep it from getting to bodies of waters. Keep it away from lakes and creeks and streams. So one way farmers can do that is they can plant buffers. And where they locate their feedlots, and avoiding steep slopes and flood zones, for instance. But if you look at these pictures down here, you see these bands of trees and stuff on both sides of the creeks. These, if we have runoff that happens, it has a tendency to come down to these trees, and then these trees and plants and shrubs can absorb those toxins and those pollutants before they get into the water source. So that's a pretty simple way of starting that problem. It helps deal with both soil erosion and it filters pollutants. So that's one way we can do it. We have a law that helps us take care of some of these things, and that is the U.S. Clean Water Act. And it basically sets standards on how much pollutant you can put into water sources. So it determines the level of key water pollutants. And so it kind of requires the polluters to get permits, and then those permits limit how much they can put in or discharge into different places. So the EPA is currently experimenting with what they call a discharge trading policy. So this is what they use for air pollution. So if you're a coal power plant, for instance, you can only release so much sulfates or nitrates into the air, and you actually basically they sell you permits, and then you can buy and sell these permits and trade these permits. But they only allow a certain number of permits, so there's a maximum amount of pollutant being allowed into the air. And so they're doing the same thing with the EPA's kind of experimenting with the same thing when it comes to water pollution. There's a certain amount of pollutants that can go into the water streams. You can buy, sell, and trade them. We'll see how that works out. An early focus of the Clean Water Act was really focused on point source pollution issues, and that was amended in 1987 to try to solve all the problems. And it's an act that kind of guides a lot of the decisions that are made when it comes to industry and agriculture and how they do business. But it will be expanded probably over the years to account for more non-point stuff, just because it's so hard to get a grasp on that they have to do something. By the way, the Act does not deal at all with groundwater, just surface water. And so that is a limitation of this law, but the Safe Drinking Act does deal with groundwater. So between the two, it kind of gets managed a little bit. Okay, so important vocabulary that you might need to know from the Clean Water Act. Water quality standards, also known as WQSs. They're based on risk and toxic levels, basically, of different chemicals. And these are the standards, or the requirements for specific areas of how much pollutant they can handle. So it's based on individual bodies of water, rivers, lakes, and streams. And then that's set and maintained, depending on what the use of the water is. So that all takes into account, and then they set the water quality standards based on that. The total maximum daily load is exactly what you would think it is. It's a calculation that basically says how much of a specific pollutant I can put into a specific body of water and still meet the water quality standards. And so the TMLD is used a lot, especially by industry, to make sure that they don't exceed that. Now, other ways we take care of our water. If you live in a rural area, you probably have a septic tank. A septic tank is basically a small-scale sewage treatment plant that's used to clean up and maintain your organic waste. Breaks it down, uses bacteria to do that. So your plumbing and stuff goes out of your house into the septic tank itself. Then from there it goes out into what we call a leach field or a drainage field. Here's the septic tank pictured here coming out of the house. Okay, so the septic tank has different levels or layers to it. The top, there's usually a manhole cover on it, and it has gas right there in the opening. So if you open it up, it smells delicious. There's a scum layer on top. There's the wastewater, and there's sludge at the bottom. The sludge builds up over time, and eventually you have to get it sucked out. The wastewater is kind of the stuff that's been cooked and treated, and it works its way out into the drainage field. The scum is where a lot of the fun action is taking place, where a lot of the stuff's being broken down. And so those are your layers, and then goes out into the field and then seeps back or percolates back into the earth. About 25%, a fourth of all the U.S. homes run on septic tanks, so it's a pretty common thing. If you don't use that, then you have a big municipal water treatment plant, which we saw when we were in Boulder, or a sewage treatment plant, same thing. And there's usually 3 stages to that: a primary, a secondary, and a tertiary sewage treatment stage. And so the primary sewer stage is what we saw when we first walked into the first set of buildings. There's a big screen, and that big screen takes out all the big, huge chunks of stuff you shouldn't be flushing down the toilet. And so a big screener that does that. The raw sewage comes in, it knocks all that stuff out of the way, and then it gets into what we call the grit chamber. The grit chamber basically allows a lot of the really large particles to be removed or settled out to the bottom of that. That moves on then into what we call the settling tank, and the settling tank is exactly what you would imply. It gives enough time for smaller particles to come out. That's what we refer to as sludge. That's the solid removal stuff that eventually has to be taken to a landfill or something. So that's the primary section. Now let's get in the secondary section. Once it leaves the primary stage, it goes into the next stage, and we saw all of these things. It goes into what we call an aeration tank, where they pump air in, and that allows bacteria to eat away at the organic material left behind. That goes into a second settling tank, which allows all that stuff that's been eaten by bacteria to work its way back down and be collected. It goes into actually a sludge digester, which eventually comes into a drying bed of sludge that then gets hauled to a landfill. Or it can be put in the ocean or put on cropland, or it can be used a lot of different ways. But it's basically organic waste. And then if it's active sludge, which means it has bacteria and stuff in it, actually can get pumped back and reused, keep the cycle going of breaking stuff down. Once the settling tanks happen, we have pretty decently clean water, relatively speaking. It has bacteria in it still, so it has to go over here where it gets chlorinated or disinfected, or if you're in Buffalo, it has UV light shined on it, and that kills off the bacteria, and then it can be pushed back out into the stream. So primary and secondary are the 2 main systems. We saw both primary and secondary when we were in the Boulder area, and we have both primary and secondary sources here. So this is the whole system, primary and secondary, all the way through. You should know this. This will be on the test. Next is what they call tertiary or advanced sewage treatment plants. This is where they have extra of a certain thing. You see, we're taking care of a lot of the organic wastes here, but there's chemicals. We haven't accounted for chemicals at all. So what do we do there? This is where we might have a tertiary system that takes care of specific pollutants, like if you have lots of nitrates or phosphates, and there'll be a specific process to manage those specific pollutants they want to remove before it's discharged. And so the water is sometimes bleached, which helps its coloration. It can be chlorinated, which helps disinfect it and kill the rest of the bacteria. And then after all that, it gets pushed out into a stream. It can be pushed into a river, a bay, a lagoon, a wetland, whatever it gets pushed out into. Sometimes it's used for irrigation. And so after those final steps, that's where it goes to. Here, a lagoon, my parents live my grandparents live in North Dakota. I was born in North Dakota. My parents used to live there, of course. Every town has a slough. A local, basically, lagoon that all their stuff is pumped out into, and then it settles out there. And so it kind of creates a natural filtration and purification process that occurs. And so that's usually one of the final stages you can have depending on the environment you're in. Sometimes there's a creek you can push it to. Sometimes it has to go out to a lagoon or a wetland. So if you look at all these tanks and stuff, this is all the stuff we walked through when we were going around Boulder, all these tanks and all of this stuff. And then these guys have a big lagoon they push it out into, and that lets it seep back into the groundwater naturally. So that's what lagoons are for. And then there are some cities that have actually went to completely natural sewage treatment systems instead of these artificial big tanks and stuff. And so this is actually a picture of one. It's the same process that happens in the primary and secondary and all of that kind of stuff. But in this particular case, it's all happening in a natural environment. So this was out in California. It's a 65-hectare wetland near Humboldt Bay specifically. And there's a town there of about 16,000 people, and all their sewage goes through this natural process to clean it the same way it would be cleaned in a specifically built sewage treatment plant. The difference is this project cost about half as much as the plant did. So the environment naturally does this stuff, and we can utilize that to our advantage. This process is slower, it requires more space, but it is more cost effective, and so there's a balance there at work. So water pollution. What are some solutions? Well, we can prevent groundwater contamination at all costs, because once it gets in there, it's bad. We need to reduce the non-point runoff. That is one of the biggest dangers in water pollution. We need to reuse we reuse treated wastewater for irrigation. Let's not just pump it back out. Let's use it for something that we have it, right? We need to find substitutes for toxic pollutants. There's not an easy way to clean those up. We can work with nature to treat our sewage better. We can use the 3 R's, reduce, reuse, recycle. That solves lots of problems. We can reduce air pollution, because air pollution eventually turns into water pollution when it rains. Reducing poverty will help out, and we can slow population growth. All of these things are the major things we could do to solve water pollution issues in general. All right, that's the end of this unit. Bye-bye.